We are live on YouTube as well. Okay, well, maybe we're not going to be live on YouTube, so we're going to keep that simple. Admit. And we are recording live on the cloud in Zoom, and then we'll go from there. All right, so I want to say thank you all for joining us. People are rolling in. We usually take the first minute to just get ourselves oriented as to why we're here and what we're doing. And every Tuesday over the last month, we started a Tech Tuesday Lunch and Learn series. And essentially, it's dual purpose to talk to people in the industry, from data science, geoscience, cloud computing, DevSecOps, all the things that we do as a team in the company. We bring in our experts as well as experts from the field to go and discuss the latest trends, what's happening in geodata science, in this case today, for example. New Light Technologies is very oriented towards participating in industry. So we attend lots of conferences and so on. So we needed a way to have a continuous engagement in the community. And this is a great opportunity to do that. Something that's low threshold for preparation, but high impact, hopefully, on the side of getting value out of it for our team as well as for the community. And today we're joined by Dr. Qiusheng Wu from University of Tennessee, and we're also joined by Dr. Ron Goldblatt, who's our chief scientist, and Daynan Crull, who's our senior data scientist, who use a lot of data science integration with geoscience, Google Earth Engine, and so on. And geemap is a topic that Dr. Qiusheng has really evolved, built, authored, and evolved to really be a great community resource. And so we thought this would be a great opportunity to get introduced to you, introduce you to our user base, our community, as well as yours in this case, because it's a global, it's online. So thank you so much for joining us, Qiusheng and Daynan and Ron. I think Daynan, if you take over the screen, I'm going to stop sharing mine. I just have a notional screen that says who we are. And for those who are just joining, please make sure your mics are mute. And then definitely feel free to ask questions in the chat, or at some points even go into being able to asking with the mic. So with that, we are going to go to Daynan, if you want to share your screen.
Yeah, let me pull that up here.
So yeah, we have a
yeah, and then I added the slide that Richard made.
Excellent. Okay. Okay, good. So so thanks, G. Yeah, I think we're excited to have you here, Dr. Wu, and as G mentioned, I've used geemap certainly in my own work, and I'm also pleased to see that some of our colleagues from the World Bank, some other data scientists I've interacted with have joined us today, and hopefully we'll get, a good conversation out of this. And just so for a little background, as I think we've discussed briefly, obviously Dr. Wu is at the University of Tennessee, and his research focus are on GIS, remote sensing, environmental data, environmental modeling, excuse me, and really applying geospatial, big data, machine learning, cloud computing, and Google Earth Engine, which we're going to talk about a little bit today, to study global environmental change, especially and he's a big fan of open source software, as are we, and reproducible research, and he's developed a number of packages, including geemap, which is what we want to talk about today. Yeah, so today just a brief introduction on remote sensing and its impact on geospatial analysis, socioeconomic analysis, environmental science, the influence of open tools, and Ron will lead to some discussion with Dr. Wu on that. And then we're going to look at Google Earth Engine and particularly the geemap package that Dr. Wu you created. And I think you mentioned you had some slides and would be willing to do a demo for us. So I think that'd be excellent. So we're going to keep it pretty open-ended here. So if you guys have questions or anything, jump in. We're not going to assume any level of expertise here. So no questions too basic or too advanced. Throw it in the chat or feel free to just jump in. But we really want to make this sort of a nice, engaging conversation. So yeah, Ron, why don't I kick it over to you if you want to just follow through with some.
Yeah. So first of all, Dr. Wu, thank you again for joining us for this talk. And I'm really excited to hear more about geemap. But maybe first, we just wanted to talk a little bit about remote sensing analysis, Google Earth Engine. So my first question to you is more about generally on remote sensing and the recent trends that we observe in the applications of remote sensing, whether in academia, applied research, or policymaking. So I wanted to ask you if you can talk a little bit about these trends and the increasing use of free and open source satellite data and derived products for so many applications. What do you think has changed over the last few years in the remote sensing domain?
So just my personal experiences, I think in general that we have more and more data. So especially the past few years, European Space Agency, the Sentinel one is also very transformative because it brings a higher resolution. So right now, I think in general, remote sensing is going through higher spatial, temporal, and also spectral resolution. So we get tons of new data. And before Google's engine actually is very difficult for general remote sensing users actually have access to supercomputing to do like large scale geospatial data processing. So I think since I started using Google's engine in I think probably 2018. So I learned about that in a AGU meeting, and then I came home and then I started. Oh, it's really, really interesting. But the point is that it was using JavaScript at the very beginning. Python was actually known really they have the API, but it's very difficult actually to use. So because you cannot use data interactively, you can only basically do the computation, and then you can request a thumbnail of the image. If you use JavaScript, you can interact, you can load data, you can zoom in, you can zoom out. So Python is not. So I learned JavaScript at the beginning, but at the end, when you need to design the GUI, I'm not good at JavaScript, so it took me a while, and then I moved to Python. But Python, you cannot interact, so I go back to JavaScript. And not until early this year that I got to know that Folium and also later IPyLib actually they can load the data layer. So from that time, I was become really interested in this in this aspect because most of my research focus on using high resolution data, for example, USDA 1 meter resolution imaging. It's just simply not possible if you're going to download the data for a state or for a county. It's going to take a lot of storage. So now all the data right now in Google's engine. So I can just write a free line code actually to retrieve the data. And the other data source I want to mention is the planning imagery. Like you can have weekly, you can have right now pretty much daily, and 3 to 5 meter resolution. I think it's also very important. Complement the, for example, Landsat and Sentinel, those relatively medium resolution, but they have more like spectral bands. So I think right now we have more and more data, and also LiDAR and other data sources. So certainly I think Google Earth Engine will be playing a big role in advancing the remote sensing community. Also get exposed to other people traditionally not used to remote sensing. So now they see the application and they're interested in this kind of a geospatial technology. So it's getting more and more people getting involved. I think overall it can advance the science and also contribute to the community. Just my personal.
Right, and that's exactly the question that I wanted to ask you. If you see any change in the type of the characteristics of users who leverage remotely sensed data, because traditionally remotely sensed analysis was done by scientists in universities, and I think that in recent years more and more end users have access to all this data and all these codes, also thanks to you, and they can leverage all this data. So another question that I have is for you personally, what is motivating you to dedicate so much of your research and time to make analytical tools more accessible and easier to use? What is your motivation?
So actually at the beginning, I was teaching an undergraduate course called Spatial Data Management here at Tennessee. And so it was the spring 2020, but earlier this year. And then because in March, we moved to online due to the pandemic. And then after that, I was at the end, I was teaching students how to manage the spatial data, but Google Earth basically has a huge data catalog. So it's the best data source that students can actually access. But personally, I like using Python. But at that time, like I mentioned, it was very difficult. It's not available. You cannot really visualize the data interactively using Python. So, and initially I learned that it was the Folium library actually can load the data, Earth Engine, the tile layer into the map, and then you can interactive. So it's very interesting. So I developed initially a package called GE Hydro because I'm doing more like hydrology research and develop a package. But as I try to implement more functions, I realized you cannot, once the map is created, it's basically static. You cannot really interact with the user. For example, user click their mouse on the map. We are actually supposed to get the coordinate and use the coordinate to query Earth Engine data. But users could not use do it using Folium because it's basically one way. Once the map is created, you cannot return things back to change the data layers. And later I learned, oh, you can use IPy leaflet. IPy leaflet is more like bi-directional. So user can click, they can select the polygon, they can use that to query data. And then once I learned the IPy leaflet, you learn a little bit more about IPy widget. So IPy widget basically is a Python package that you can develop a lot of interactive GUIs and then use that actually to accept user input. So user can enter something and then you can based the user input, you can query the data and then you return the data layer and then can display, do all kind of plotting. So that's along the way that when I discovered those like packages, I found, oh, it's really amazing because I didn't realize that you can do a lot of things that you can do also in the JavaScript because I saw many things only available in JavaScript. So I was trying to implement the counterpart that just to make people can easily use Python, just like what they're using in JavaScript, but trying to simplify the process. So in JavaScript, you might need to write, for example, hundreds of lines actually to do something, but I try to implement the same stuff, but you only need to just call one function. So simplify the whole process so the user don't have to like write a lot of lines. And I think that's my goal. So initially just for my students and also for myself personally, for my research, but I released to GitHub and it looks like the community like it. Then I continue to develop. And from time to time, I learn a new package that you can actually do something new and then just implement those new features and then continue to build up. Also, a lot of the users report issues on GitHub. So I resolve those issues, fix some of those bugs, and people also make some feature requests and implement. Also, I mean, thanks to LinkedIn and Twitter, social media, I saw a lot of new stuff. And people might use other technology, but I see, oh, maybe I can implement this one. So I try to borrow some of the idea at the end, just slowly. So I have more and more functions right now incorporate in the package. But I have to say that I'm not a computer scientist, so my package might not be the very best like most efficient, but for me, I think it gets the job done. If more people get involved, might be able to improve and then make it more like a robust package. Right now, it certainly has a lot of bugs, but I think it's a good starting point that show people how to actually access geospatial technology, how to access cloud computing, because most people, like when you hear about cloud computing, they might need or write a lot of lines of code. But right now, you can just open the browser, you can use Google Colab, and can do a lot of things very interesting that you're not able to do in the past. So this is just my personal motivation.
So we will show all these tools in a few minutes, but maybe before we delve into the tools, let's talk about Google Earth Engine. I love Earth Engine. I've been using it for many years, and I think that many of the those who attend this talk know what is Earth Engine. But for those who do not, if you can briefly explain in a few words what is Google Earth Engine and what is the difference between Earth Engine and other platforms used for geospatial analysis.
So basically, it's a cloud computing platform that Google built and for you to access multi-petabyte data set just using the browser based. You can also access the API. You can think about, I think I gave an analogy before, like what's the differences, for example, between Google Earth and Google's engine. So Google Earth, for example, you can only view the data. So let me maybe just ask a simple question. We always see that, oh, the landscape is changing, urban is growing. But if you, in the traditionally, if you use Google Earth, you can only see like, oh, it's changing, but how much? We want to ask some quantitative question, like how much it's changing, how much the deforestation is going on. You cannot really answer using those imagery. So Google Earth Engine basically give you access to the data set, and then you can run, design all kind of algorithm to do spatial analysis and can get the result. You can put the plotting, you can export the result. So it's transforming. 5 years ago, before I used Google Earth Engine, I have to go to different agency to download the data to my computer. I need to do mosaicing, need to do some atmospheric correction. I need to run the algorithm on my computer and make sure that I have storage, I have the space, I have computing. Now it's not. You just need a browser. You can do that in your iPad, you can do that in your tablet, or even using your phone. So all you need is just a browser. And I think it's very, very powerful, and it's free. So there's nothing you can do. You can try it out and see what it takes you, but it cannot do everything that you can do in the traditional remote sensing. But I think it's still improving. So hopefully it will provide more and more functionality in the future.
Right, and yeah, you mentioned that it is free for use for non-commercial use, and Google is a private company. And I think that only in the last third quarter of this year, its revenue was around $46 million. So what do you think is Google's motivation to continuously develop such a powerful platform? Do you think it's purely for public good? Do you think that in the future, Earth Engine will not be free for non-commercial use? And I know that people talk about this possibility.
Yeah, I think this is a concern that also many people have, because they know that Google have released a lot of products, but they also kill a lot of products in the past. So many products that people like, but Google killed it anyway. So I think Google Earth Engine right now, as far as I know, they have a full-fledged team. So it's not going away very soon. And because it has a lot of impact in the academia, also have a lot of application in the general public, I don't think it will go away in the next few years. Hopefully not. One thing that I think Google Earth Engine is also using this one is because they have some other department. For example, Google Map, especially for those emergency management, wildfire and landslide or flooding in those countries. They actually, behind the scene, they use Google Earth Engine to power up to give user warning. So right now, for example, if you have wildfire going on in your neighborhood or something, when you do Google Map, it will pop up. So the technology is being used both by those departments within Google or also Google Earth. So I think that technology is needed for them actually. Whether they are going to use it for public good or not, I'm not an employee, so I cannot really say that. But I think at least for the next decade or so, it should be there, because they also have the Google Earth, the Google User Summit every year. It has attract a lot of attention, and also a lot of for example, non-profit, for example, National Geographic, they have a lot of product. They also have working with European Space Agency. So hopefully it'll be there. But to me, if Google also is going away, there will be some other alternative coming up. So the technology right now is improving. So it's more like once you have the prototype or have the model, other company can actually have build some similar stuff. And so behind the scene, I imagine that, for example, geemap, although it's first for Google's engine, but if there's some other company, you can also do something very similar. So the analysis can be similar to something like in the deep learning community, right? Deep learning, you have TensorFlow, but you also have Facebook and different company. They also have different framework, different backend. So at the end, we can have a package that actually that user choose different backend. So in the future, Gmap like user can choose Earth engine, but for example, NASA might come up with a different like cloud computing. You can choose the backend. So the idea I think is more important than actually what the technology is using. It's more like the framework. So that's just my thinking. So if Google Earth engine is killed by Google, then Gmap probably won't work anymore. So I need to come up maybe with another package or use other technology.
Right.
I think what somebody on the chat just highlighted, I think Sunita Yadav,
Mhm.
Google has also entered into agreements with the federal government, makes it more likely that the GE is here to stay. They seem to be working out the commercial aspect. Thank you, Sunita.
Yeah, thanks, Sunita. I think, yeah, Sunita, we went to the same university, Cincinnati. So thank you
Okay.
for that. It's great to know that Google has entered agreement with a federal agency, but as far as I know, for example, NASA and some other federal government, they don't allow the employee actually to use Google Earth Engine. So that's just it might change. So,
Yeah.
but as long as it has some relationship with the government, they have the funding, so it might be more sustainable. That's a good, really good news.
The last few years, actually, Ron, I know you and I talked about this, is that there was some some parts of the federal government that were interested in charging for remote sensing data
Mhm.
going forward at some point. I think that conversation has slowed down,
Mhm.
but I think that might have more of an impact. I don't think Google's like you said, Qiusheng, that the use case for Google is more driven by internal needs versus consumption by
Mhm.
academia and others. But that was something that has come up before. I'm not sure where that's going at this point. One thing that I wanted to, if you don't mind, one of the reasons I got connected to you was I was really impressed. The time lapse series
Mhm.
went viral over the last month and a half, 2 months, I think maybe.
Mhm.
That's when I caught it at least. Everyone was starting to make at least hydrological views of time series using your web app.
Mhm.
Uh, how did that come about? What was your thinking for that?
So initially, actually, the time lapse. There's another Earth Engine user, Justin. He's right now also a Google employee. So
Yeah.
he actually developed a JavaScript version of that time lapse. So you can draw a rectangle, but it's not like one stop. You have to download the imagery, and then you need to do some additional
Yeah.
post processing, and to add label, add text, add other stuff. So at the time I was thinking maybe I can maybe have some a Python like version of that like an app. So he actually contributed some of the source code for that time lapse, and then I use some some more like interactive components. And actually I published it one I think 2 months ago. But the reason why it gets popular now, because in the past it's a Jupyter notebook, so people actually have to download the notebook, they have to install Gmap, and it's a lot of steps before you can generate the time lapse.
Uh-huh.
And I think 2 months ago I learned that you can actually use Heroku or Angular, some of the open source. Heroku is not open source, but you have some free plan that you can deploy apps to their server. And then I also learned like a Voila, so it's another package that you can turn a Jupyter notebook into a standalone web application. So basically, if you have the Jupyter notebook, it can be a website. So all you need to do is just deploy the app to the server, and then when you click the link, it will run the Jupyter notebook, execute all the source code, and then display the results. So, and then as I learn the process and then try to implement at the end, right now user can just go to the URL, they can just start, and that start things to change because it lower the barrier. Users don't have to have a Google's engine account. They don't have to install everything, just browser. And so once it
Yeah.
gets easier, people like it. And you might notice that the server is down from time to time because too many people are visiting it's free. So sometimes you have a lot of images downloaded to the server and it froze the computer because the storage
Yeah.
might be full or whatever. Then I have to check the website and reboot it from time to time because I received some notification from LinkedIn or Twitter asking, the website is not accessible. And then
Right.
I know. But later I also noticed learn Voila, you can actually have some settings to when the user open the browser, when it's idle for 2 minutes, you can shut down the kernel. Otherwise, when I think Voila has some limitation, when over 20 or something, it's you can open more files. So now, if I kill those idle kernels, it can actually keep running. So now I really have to restart the server. I think that's also one good thing. Keep me from. I was amazed that you always learn something new, and then you can make things easier. And
Absolutely.
it's all thanks to the open source community. So I learned from them, and I would love to contribute back to the community.
Well, you've done a great job contributing back, I think. So I'm going to stop there because I think you guys, Ron and Daynan, have a couple more things to cover. But I was really impressed by it. That goes to your question, Ron, earlier about more people learning and using about the remote sensing data that's out there available, very powerful. So I think you did contribute.
Right.
Use case.
Yeah, so I think that now we are all eager to learn more about the tool itself, the packages, geemap. So I will head it over to Daynan to talk about the technical component of geemap.
Yeah, thanks, Ron. And good conversation. I think on that note too, we've mentioned this before, that when you're looking at open data, it doesn't just mean free. It doesn't just mean you get information or tools for free, and you don't have to pay a license perhaps, but the time it takes to make use of these and to make meaningful use of it is work involved. And so I think in the open source community, thanks to the often heroic efforts of people like Qiusheng, we have packages that we can use. And so, geemap is one of them. And so I'm going to, again, share my screen here. And I'm certainly not going to explain geemap better than the author himself. So for those of us who are not familiar with the package, I just want to open up some links to the, and we'll share this with folks, of course, as a follow-up, but geemap.org. And from there, you can access the repo documentation. And I just want to, point out that there's a tremendous amount of work that goes into not only developing a package like this, but providing the documentation in the tutorials. Truly a lot of work, and I think it shows, Dr. Wu, you're a testament to your focus on users understanding and using this package, and so they can do their work. And so I'm going to kick it over to you here in a moment just to actually talk about geemap. And I know you, maybe if you have a slide or some demos, would love to just sort of have you walk through the package. But you mentioned something that I just wanted to, I thought was an interesting point, that, your background is not as a computer scientist or a software engineer, that you're, like many of us, myself included, have a background in other scientific disciplines or analysts, and find that we have to wear two hats. On the one hat, we wear experimental design, research, we have to do that kind of work. And then the other hat as a developer, where we have to work with the tools to actually work with this data. Clearly you've straddled both. Is there a side that you find yourself spending more time in, or is there an interest that you have? Is it developing and expanding on packages like geemap? Or do you often find you'd rather spend your time doing this sort of research, and as those tools become available, you would want to spend less time having to develop them? Or maybe it's both. I don't know if there was a particular place that you've landed.
Yeah, I think during the past few months, I did spend a lot of time developing the package, but so I spent little. I think in the long term, it's going to benefit my research, because right now I need to write a few lines of code just to do some spatial analysis. In the past, I have to write a lot of lines. So although right now I spend a lot of time on this package, but it's going to be save time later. So I spend more time on this and less time on my research right now at the moment. But slowly I'm going to move back to doing more research, because once this one is built up, I may add more features, but it might not be as frequent as what I did in the past, because in the past I released a lot of new features and other stuff. So right now it's kind of slowing down. I also have, I need to go back to my regular job, just teaching students, and also work at my university. So, but my goal is to lower the barrier. So I want to bring in more people to use geospatial technology, and also to contribute, because in the past I used a commercial ArcGIS and MV and other software, but now with this, I think we can less rely on those commercial stuff, and people can bring a lot of new stuff, and we can all build together. So I welcome all the contribution that the user, or you can use new feature requests or report a bug or whatever. It can make the package more robust. And I also learned a lot of new things. For example, even for this website, initially I was using the read the docs.io. I'm not sure if some of you might be familiar. It's less like this one looks more modern. Some of the website might be a little bit outdated. So as I learn something new, I try to implement that, and so the user can always have access to the latest one. So this was my goal, and I'm also going to use this one personally in my teaching here at Tennessee. But it did take a lot of time because for those videos, it's right now I think over 10 hours. But I can say that it took me many times of those 10 hours actually to develop. It's not about like record the video like 10-15 minutes. It's about developing those functions that used to demo in those videos, because those sometimes take a couple of days actually for me to implement. Especially at the beginning, I was not familiar with IPy widget, how to develop those components, how to have those interactive GUI that people can just click a button or click the drop down list and select something. It took a long time to learn, but it's a very fun learning process because it can make life much easier. And you also, at the same time, you can make the user life easier, because right now they can just do the same thing without writing many lines of code. So I'm happy to see the positive feedback from the community. So I will continue to contribute and develop the package, but I welcome any contribution to the package.
Great. So yeah, I had a couple more questions I could ask you, but what I would love to do is dig into actual walk through Geemap, talk about what it actually is, highlight some of the features, maybe do a demo. So Qiusheng, I don't know if you want to take over and do that, if you want a demo or something like that.
Yeah, I can quickly maybe use 5 or 10 minutes, something like that, to quickly show you some of the key features. And I do have a slide that I can show if you want.
Yeah, so if you can, why don't I turn the sharing over to you?
Okay. Where's the... Can you see my screen now?
Yep.
I'm not going to go over the entire slides, but just to show you some of the key ones that where can you get access. Ooh. Looks like I have some. 1 second, let me again. No, this one, sorry.
Take your time, and just while you're getting set up there, we do have a lot of use cases on our side for projects that we do where our team builds packages for customers and partners, and so it's exciting to see the growth in the industry and use cases and bringing it to the public. Essentially, what you've done with that time-lapse one. I was telling you my interest is also in water and water conservation and understanding water, and that's a great tool for the time-lapse.
Can you see the my screen now, the PowerPoint?
Yeah, we see a screen,
but not the PowerPoint.
We did not see no, just the background.
Okay, let me. I'm using kind of Linux, so I just updated my system. Looks like some of the drivers, the video driver is not working properly. Let me.
Okay, and I think Daynan, you might have something to display too.
How about this?
Yep.
Okay.
Yep.
If a full screen looks like it's black, so anyway, let me just.
Yeah, just go through it like that.
Yeah, just go through quickly. So if you would like to try it, by the way, so I put the links in the chat box. You can click the link to access the slide if you want.
Yep.
So it's gshub.org/NLT, and so here's where the one that's getting popular in the LinkedIn and the social media. You can try out the web app. So the first one is using Heroku. The second one actually is my local computer, so it's a server. and it just is a backup. So in case the first one is down, you can try the second one. And the notebook, so everything is open source. You can take a look at the source code, how I actually developed the app. So this is all behind the scene. And so technically, how did I actually develop this one is initially you just want to show the map. So when the user open the link, you don't want to take too long to show the map. So you don't want to do any computation when the map first load up. So only after the user draw a rectangle or something. So it loads much faster. I think this be one thing that if you want to develop something similarly on Earth Engine app, you might want to take a look at this. So everything here, this is the key, is the function how to add the time lapse to the map. So these are all actually retrieving all those parameters that the user select. I don't want to go into detail, but just something that I want to point out if you are like an advanced user, you want to develop something like this. So again, I also make some tutorial show you how actually to use the app. So everything that now you see here in the upper left corner, those are widgets. So everything is developed using the Api widget. You can have drop down list, you can have button, you can click, but behind the scene it's kind of complicated because when user click something, you need to hide something else or whatever just to make it more coherent. And then you can change the title, you can select different bank combination. So compared to Google Earth actually also have the time lapse, but it's a lower resolution and you cannot change the bank combination. So this one actually is much better that you can switch to highlight different features that you want to highlight. And initially it was just the time lapse, but later I also add the normalized difference index. So user can extract water, vegetation, anything that you can, something you can do, you can extract using normalized difference index. And you can also download. So the earlier version, you cannot download the image. You have to run the notebook on your computer to generate. But so I learned Voila, and then there's something that you can use to actually to give a file from your the server, and then the user can actually download. So that's why you can, people can create those animation and then put it onto the computer. So those are some of the examples we can see. It's very, very interesting to see how the landscape is changing. And within the 37 years, there's some example. Particularly, I like this one, this landslide. It's just amazing to see that last for almost a decade, right? It's the last landslide. You might not notice when you are on the ground to see that because it's like slow moving, but it's a long time, you might be able to see that. And coastal expansion, for example, urban growth, you can do anything. So it doesn't matter. It can do it for any location. I'm going to skip the Python API. So initially, so this is the differences between the Python API and the JavaScript API. So the Python API, you don't have these components. It does not interact with the map, or you cannot query the data interactively. So everything here right now, most of those have been implemented in the geemap. And again, it's open source, so you can check GitHub. And so one thing that for users they feel intimidated to install the package on local computer, you can try Google Colab. So now Google Colab, I also have some template here. Just click, as long as you have the account, you can just open, and then you should be able to run the source code. So I try to make it easy. If you go to my GitHub, you can click the icon and just to launch the source code and then to run on Google Colab. So recently they added another one, so you can mount your Google Drive, and then once you mount the Google Drive, when you execute, it's going to save the Earth Engine token to your Google Drive. So next time you can automatically load the token. In that way, you don't have to authenticate Google Earth Engine every time, because initially I don't like it because every time you authenticate, you get an email and it's just very repetitive. So now you can save the token, so it saves you a lot of time that you don't have to go through the annoying process.
That's a nice little innovation there. I like it. I like it.
And also the new domain. So now it's much easier, geemap.org. So I have to pay out of pocket. I think it cost me a couple $100 to actually to buy the domain, and for several years. And the YouTube channel, it goes quite popular. So now almost 3,000 subscribers, over I think 60,000 something views. And I try to make a video every week, but I was overwhelmed the past week, so might need to go back to that next week. And so all the video, animation, notebook, I realized that not many people have time to watch the full video. So I try to make some highlights every 15, 20 seconds. People can see what's going on with this video. You always have the notebook, so everyone can actually reproduce what I did exactly. And so those are some of the key phrases. The first one is actually, this was the first feature that I developed on the package, is to convert the Python JavaScript to Python automatically. It's not perfect. If your Python, your Earth Engine JavaScript has a lot of like interactive components, GUIs, it's not going to work. But for computational scripts, everything is automatic, so it saves you a lot of time if you're trying to transition from JavaScript to Python. And also this one took me a lot of time, I think several days actually to implement, is to bring in those data search. So you can search the Earth Engine data catalog, click on a button, and then you can import the data and then to run the data. So in the past, I have to switch always, go to the Earth Engine website documentation to search the data set, figure out the ID, and then bring in here. Now you can do everything here within the notebook without having to switch the browser and also the base map. So this one is not available in the JavaScript because it's limited to the JavaScript, the code editor. You can only have those Google base map. You cannot bring in other web services. I think this is very useful because a lot of data set out there you can bring in, and then you don't, in that way you don't have to download the data to mosaic the data and something like this, left and right, so you can see before and after to compare different data sets. Also, this one I think is also very important. Just like identifier, click, you get all the values, and so it's much easier. If you don't want to implement this one from scratch, it's gonna take a while because a lot of components involved. And what else? Also interactive plotting. So if you need to see the spectral signature, you can do that very easy. No coding. So I did the coding so that you don't have to. And also time.
On that note, quick too, I'll interject that for those of us that love Python, one of the reasons we do is like the NumPy package, for example. Mm-hmm. And I know, Dr. Wu, the conversion of a bounding box of an image to an array and to a NumPy array is something that's possible, I believe, with geemap. And
yes, it's possible. So I also have a function called EE to NumPy. Let me go to the repo here just to show you. So anytime if you need something, you can go to my repo or you go to geemap.org. And this is the way that why I like this new the documentation website, is that you can search, for example, if you just search NumPy, quickly you can find out like which function like related to NumPy. So you can go to specific this one, you click E to NumPy, and then from here you will see the function. You can see all the parameters. One thing I really like is you can see the source code behind, so you will know exactly how that function was implemented. So you also need to pass on also any object. If you want to select a specific band, you can do that, and you can specify a region like a rectangle. And then from there, you can see this is the source code. It's not very complicated. So the function here, the most important one is sample rectangle. And then so this is the code that you can convert, but it's not going to do that for a large area. It's good for small size that you want to do some testing, but certainly you don't want to do that for global scale or national scale when you have too many pixels, because at the end, the data from in the Google's ending server, everything need to come down to your local client side. If the data is too huge, it's going to take a while. So you don't want to do that for a large area. But
yeah, and that's certainly a restriction of the API, which makes
yes.
You can't move that
so
data.
There's a limitation that you can change for data to the server, also get the data down to the client.
Yeah, and if you are, if you like, say, the Seaborn mapping package in Python or some of those other plotting libraries, to be able to convert to NumPy super easily with geemap, and then you can make time series, you can do other kinds of plots with that. There's a lot of things you can do once you've got it into an array or something else that you can work with. So I think that sort of conversion into the Python ecosystem is quite powerful.
Yes, so right now,
And
most
so,
of the plotting right now in the package, I use a BQ plot because BQ plot is also built on Api leaflet, Api widget, so you can really interactive. But I haven't spent a lot of time to improve those features. So in the future, I might add a few more like new features. User can actually customize the plotting and then to maybe utilize more plotting packages.
I was just going to say we have 15 minutes left. And so if people have questions, just make sure you get them typed up. And Qiusheng can excellent. Someone named Sunita earlier. Do you have a tool to show spectral signatures for a user selected polygon on the map? So there was a signature piece, I thought.
Yes. So if you want to, so that one basically is called interactive reduction. So user can draw a rectangle and then can do like statistics and then for example get the mean and then can get the spectral signature. I think I have a tutorial, probably it's number 34 something if I remember correctly. So yes, so number 34, interactive extraction of pixel values and interactive reduction. So if you can click the animation to see what that one look like. So user can add the data layer and then can create the plotting. You can draw a rectangle, you can click a point to actually get the statistics over a specific region.
That's something Daynan you were bringing up earlier. For me, I'm a novice NumPy user, and the power of converting it to matrix like that for data science is pretty powerful, right? I mean, you take it from there and extend it.
Yeah, it's kind of like the movie series The Matrix. Once you start working with matrices, that's how you see data. So for those of us that do that, that's how I see images too. So for me to be able to convert it into tensors and data like that, especially if you're working with deep learning, because now you're needing to convert into tensors and looking at things like classification or object detection. And so to be able to shift from a raster file into a numeric array like that. Not only for plotting, but for computation and modeling is great.
This one here I saw on my PowerPoint. This one is using like local raster dataset. So this one behind the scene is using the X array. I'm not sure how many of you use X array leaflet. So that one is basically all the matrices, all the NumPy, and then all NextDF. You can handle a lot of raster data, and to use that to compare with us in the dataset. This one is still have a lot of potential. I don't have time to actually add a lot of new features, but certainly this one in the future. So basically make it more easier for you to integrate with your local raster dataset with Earth engine data. You can maybe be able to transfer and then do some interaction, but
well, that tool, that NumPy conversion allows. So I was actually doing a forest classification overnight. It took 8 hours, and with NumPy that would have probably took 5 minutes or less. You're doing large scale classification on pixels and signatures. So the power here is that you've got Python and geemap and ability to extract data then for your statistical analysis and classification, and then throw that back to the raster viewer. We do have another few minutes here. I wanted to make sure that we didn't run too late. If there are any other questions, we have another 8 to 9 minutes. But keep going with your presentation, Qiusheng. I really wanted to see where you were going to wrap it together, I think.
Yeah, I think most I already introduced. So you're welcome to check the slides for more information. So I think the last one I show you here is the app that I built recently. In addition, so in the previous one, you can create a time lapse, but those are just for users that just want to see the changes. So this app actually add a few more things that for you to actually do quantitative analysis. For example, you see the water is changing, you want to know like how much is it changing. So you can use this one to extract all the statistical results. For example, the water area for every year. You can show the plot right away. You can also download the statistics to your computer. So again, this one is also on the web. So you can click this one to open the web app, and then you should be able to do that. You can customize this one to, you don't have to customize. You can draw a rectangle or a polygon for any location, and then it's going to composite all the time series and then do the statistics. It can be water, it can be vegetation, it can be anything. So This is another app that more like tailored to like science users. You want to do more. It's not perfect because this is just using the normalized difference index. It's not going to do that perfectly, but you can usually just click your mouse on the map, for example, and then to select a polygon. This is just for the US, but you can add, for example, other polygon for any other states or other country. You don't want to make the polygon too huge because there's a lot of computation. It might time out, but once you have this one, then you can customize these parameters and then just hit submit. It might take up to 1 minute. Then you have the statistical results. So this one is giving more insights beside the time lapse. And if you put these two together, you have the time lapse, you have the statistical result for every year. Then you can really show this one to people how the landscape is changing, at how much, what kind of rate.
While you're doing that, Qiusheng, I know your background is you're a research scientist and hydrologist is your area. Love to hear more about your use cases in that. Obviously, hydrology touches everything from weather issues, hurricanes, flooding, and so on, to consumption issues, and obviously climate change. How are you starting to use? I know you built a lot of this for your research work. What's your research topics currently, and how are you?
So my current research is focused on mapping wetlands and surface water. So mostly using high resolution, for example, 1 meter resolution net imagery. And I can show you, let me see in here, yes. Not this one, sorry.
And while you're doing that, Daynan, I don't know what kind of recap and closing stuff you have ready, or I would like.
Yeah. So first, I shared in the chat, and Qiusheng, I hope it's okay for us to distribute your deck broadly. Would be,
yeah, feel free to. Everything is open source, open access. So you're welcome to this.
That's what I figured. So we shared the link for the deck that you're looking at right now, everyone. And in this deck, you have links to documentation, the tutorials. Geemap.org, of course, is the site with all that information too, and it's nice and cleanly organized. Again, a testament to the work that you put in, Dr. Wu, to make sure this is accessible. But yeah, look, I think there's a lot we can talk about in terms of the benefits of open source, but until people step up and actually develop packages and ways to do that, it's more theory than anything. And so I think we have to appreciate people and packages like Geemap that we can actually use this work. So I really do. On behalf of myself and my analysis, I appreciate you putting this package out there and taking the time today.
Yeah, thank you. That it's really great to hear that actually that my time is well spent because people can also benefit, and that's the point. So happy to contribute.
And I know you inserted this there, Ron. You were asked this question. I'm curious if you have a minute or two, are there any interesting projects you're working on currently, either related to Geemap or else in terms of open data? That you thought might be interesting to point us to or to highlight?
Yeah, so my focus is, like I said, is mapping wetland inundation dynamics. So this is one of the projects that I have been working on. So initially this was using JavaScript API. So now I try to transition everything doing the Python API and also Geemap. But I can show you some of these examples. So for example, mapping wetlands using 1 meter resolution. So all you need to just click your mouse on the map and then select a watershed. And then it's going to retrieve all the data, do all kind of computation, and then so everything is automatic. You don't have to. You can adjust the parameters, but things are happening automated, so you don't have to have the training data. You don't have to do anything, and then you can extract those wetlands and surface water in pretty much real time. So you can do that for any location. So this is the project that I'm focusing right now, but. So there are a lot of applications. You can do forest, you can do water, you can do urban. There are a lot of things you can do. So the power of Earth Engine is allow you to scale up. So it's no longer that you are constrained to a certain area. The more important right now is that you can focus on more on the science question, what kind of question you're trying to address. If you can work out a methodology or framework for a small area, Google's engine likely can help you to scale up to do national scale or global scale. And it's not going to be perfect, but I think it's save you a lot of time that you don't have to download the data, you don't have to rerun everything. Everything is in real time, so we can quickly do some prototype or some testing. Once you figure it out, then you just scale up and apply to any other location. So this is something that I think is a game changer, at least for me. Nowadays, I don't really have download any data set. Everything is online, and then you can see here, this is like 1 meter resolution, and you can see intermediate, like you have a lot of steps or lot of data layers that delineate based on the LiDAR data, area imagery, and they can extract the surface water pretty much instantly. It might take some time to load the data, but this the limitation that sometimes you can time out, or it might take a while to get the results. Yeah, you can also go to my website. You see here, sometimes it's, okay, if you see the blue color, so those are the water area, and this is all 1 meter resolution name imagery. It's just not possible in the past that if you want to do it for large area. Yeah, that's just my kind of ongoing project right now.
Yeah, excellent. And this and other projects are available at, I think it's wetlands.io is your research blog,
Yes,
right?
yes, yeah, everything can be accessed from my website.
I think that link in the that link's not live, but I'll reshare that with everyone. But yeah, there's geemap.org is the other link, and obviously the link to the deck that Dr. Wu is sharing with us has all this information. Are there? Yeah, we just have a couple minutes left. I just want to see if anyone else has any sort of last minute questions or comments or anything they'd like to mention. And I really appreciate everyone joining our discussion today. I appreciate you set this up, G, because I think there's a lot of interesting. I mean, last week we talked about storytelling, and that's a pretty broad concept and incredibly important. And innovation is another big idea, but we can also balance it out with really practical things like how you actually use Google Earth Engine within the Python API and the amazing package that Dr. Wu developed to help you do that. So we'll have more of these. If you signed up and registered, hopefully you'll get an indication of that. But yeah, is there any sort of final thoughts or questions from anyone on the call?
Yeah, I can add one more point. So most of the tutorial right now available on GitHub. You will see here from 1 to so by 42. But you also have a lot of this in here. I haven't numbered yet. So those are some of the tutorials sometimes I'm working on, but I don't have time to basically record and make a tutorial. But certainly those are things that you can also explore to see what's out there. And some of those actually from my project or from like online, I learn and then I adapt. So I think over like 60, 70 or something like that. And the other one is the novel example that I converted from also in JavaScript. So you want to check out this one. Anytime if you are doing that for using JavaScript, you want to do Python, but you cannot figure it out. You want to look at this example because this is from the official documentation. So pretty much you can look at the catalog. I think recently Google changed the website, but most of things are still relevant. So you want to look at this example and to see some of the minor syntax difference between JavaScript and Python API.
That's great. Well, I was going to ask this question. I don't know if you can say this briefly, but are there any inspirational words of advice you would give for anyone in terms of if they were looking to develop their own open source package? Maybe in just a few words, what would you say to folks like that?
Yeah, I think certainly you can learn a lot from those open source packages. So from my personal experience, geemap is built upon of a Folium and IPyLib. So if you're doing something in the interactive mapping stuff, you personally want to look into these two packages, but you are more like looking at like computation and some spatial analysis, GeoPandas or XArray in the vector and raster like a space. Those are also very important. So I don't know a lot about them, but those are also something on my to-do list. I want to learn more and incorporate some of those capability into the geemap. So hopefully in the future, I will also maybe add some new feature that user can just interact with the map. They can create their own web app without having to write code. So it can allow you to select data set. You can customize your study area, and then you have an app directly, and then you have a link you can share with anyone. So trying to further lower the barrier that user can also share, for example, the app they created. So maybe something like app gallery or app creator, something like that. And then, but it might take some time. It's just something in my mind that hopefully in the future I can bring in. So if you want to learn, like, for example, how the package is built, you want to do something similar, for example, you want to create another Earth Engine package, you can learn from my package, or there are a lot of things out there. So you can look at the source code, just look into that, see what's in there, what's the structure, and then after you can do something very, very similar. I think I can cover right now.
Open source, everything is available for you to look at. Absolutely.
Yes.
Well, we are just over time, so I just thank you so much again, Dr. Wu, for joining us and giving us an hour of your day, but really more than an hour. Thank you for the thousands of hours of work you've done into developing this package and the tutorials. You've got a fan club here, I think, based on the comments, and I'm sure there's more out there. So keep up the good work, and thanks again.
Yeah, thank you for the invite. Really enjoyed the talk. So looking forward to talk to you soon.
We love it. Thank you so much, everyone. And again, we are going to keep this going on a weekly basis. So anyone who's on the call, whether they're internal team members or folks who've joined today from outside of New Light Technologies, we invite you to help us by being participants in our weekly meetups. I think I did put in the chat, Dr. Wu has a lot of contact information. Go to his website. If you want to reach anyone of us, definitely email our team at rs@nltgis.com. And we definitely love collaborating and helping out in the community as well. Have a wonderful day.
You too. Thank you. Take care, everyone.
Thank you.